Hi students, the continuation of the previous video. Here is the internal structure of heart. See here, these are the two valves which we call as the AV valves, what we said previously. These AV valves generally during systole of these ventricle, correct? They have a chance to bulge into the upper two chambers. Am I right? Upper two chambers, it may bulge. To prevent that bulging of these two valves, AV valves, see here, if you apply the pressure here, these valves during the systolic ventricle systole have a chance to bulge into the upper two chambers. So here, to resist that one, to prevent that bulging backward into the atrias, here is this is the wall of muscular ridges of ventricle. You know that ventricle walls are the thicker than the atrial valves. So because of it has to pump the blood very far from the particular area. Here these muscular ridges we call as the columna carneae, the muscular ridges of internal inside of the ventricle called as the columnae carneae. What do you call? Columnae carneae. These muscular ridges, some are pyramid in shape, or the triangular ridges are there. We call it as the papillary muscles. These muscular ridges called as the columna carneae, that which are have a triangular or the pyramidal in shape, we call it as the papillary muscles. Now these valves which are have a fiber or the thread-like structures which attach to the papillary muscles. Here also have the same papillary muscles there. To the papillary muscles and these aperture which have a connection is there, like a thread-like structures there. We called as a chorda tendinae. These are called as the chorda tendinae. Chorda tendinae. Now here these two AV valves are attached to the papillary muscle through the strings called as chorda tendinae. While systole happened, these should be pulled down to prevent the bulging of these two valves into the atria. Okay, that's the reason these chorda tendinae is very essential. Chorda tendinae is a fiber-like structure which attach these valves to the papillary muscles of the ventricle. And here from the AV valve, atrioventricular valve is there. AV node. This is the nodal tissue. Nodal tissue there. SA node and AV node. From the AV node, small fibers which are spread whole over the musculature of the interventricular septa. So these musculature, these called as these fibers we called as the whole over the musculature of the ventricle, we called as the Purkinje fibers. Purkinje fibers. These Purkinje fibers, they are going to divide into left and right branches. They made as a small bunch. We called as the bundle of His. Bundle of His. Okay. Purkinje fibers. What is the function of Purkinje fibers? Means they conduct the action potential from the AV node to whole over the wall of the ventricles. It will be conduct the impulse from the AV node to whole over the muscle of the atria. Moreover, SA node called as the pacemaker. It means it can regulate the heartbeat. Means what? Contractions and relaxations. That's called as a pacemaker. This should be regulate the rhythms. AV node, SCA node is the pacemaker. AV node is called as the pace setter. Pace setter. Got it? And moreover, these systolic time, the blood goes into the lower chambers, from the lower chambers to remaining vessels, which are the systemic aorta and pulmonary artery. They should be reached to the respective organs. Now here see that cardiac output. Cardiac output means stroke volume into number of heartbeats. Stroke volume into number of heartbeats. Here a stroke volume, cardiac output is equal to stroke volume into number of heartbeats. Stroke volume is a 70 ml into heartbeat 72 times per minute. It will be 72 per minute. Together it has a 5040 ml. It means nearly 5 liters. Nearly 5 liters. So here is the stroke volume means the volume of blood is pumped by the each ventricle during the cardiac cycle. Each ventricle, how much ml of blood is pumped? That is the 70 ml. 70 ml is the stroke volume. The cardiac output is the 5040 ml or the 5 liters average. Cardiac cycle means the sequential events of cardiac cycle. The sequential events of the heartbeat means what? Systole and diastole. Systole and diastole should be happen simultaneously per minute in the average, that in the normal physical condition. These are the upper chambers are the atrias, systole, diastole, systole, diastole. These will be like this happens. Systole and diastole. Okay. The contraction of the heart chambers called as systole and relaxation of the heart chambers called as diastole. Now here cardiac cycle means the sequential events of these series of systole and diastole called as the cardiac cycle. Here cardiac cycle have the total duration is 0.8 seconds. In this we have to find out atrial systole, it takes 0.1 second. Atrial diastole, it takes 0.7 second. Meanwhile ventricular systole, it takes the 0.3 seconds, and ventricle diastole, it takes place 0.5 seconds. Right? Here is a 0.1 for the atrial systole, 0.7 for the atrial diastole. Okay, anyhow systole it takes a less time than the diastole. These together it has a 0.8 seconds, but it is 0.8 plus 0.88 will be as a 16, but should not be like that because of what both should be happens in the simultaneously. That's the reason it is a 0.8 second is the cardiac cycle. It total cardiac cycle takes place 0.8 seconds. Okay, here is the joint diastole is there one step, and systole of atria and systole of ventricle. These all involves the cardiac cycle. During the cardiac cycle only the blood pumps upper chambers, lower chambers to systemic aorta and pulmonary artery respectively, then to the body part. Okay, this will be happens in the what you call cardiac cycle, and cardiac output is the 5 liters or the 5040 ml. Got it? Thank you.